Hello guys, welcome to my channel Code Doctor. Today we are going to talk about how tech giants like Amazon, Facebook, Google, or the companies like Booking.com and Expedia, they scale their databases to multi-million users. So the idea of this topic comes from a tech talk where I recently gave a talk on uh, learn to scale databases to multiple users on hellomeets. So this was a paid event and limited to 50 seats. So that's why I decided to share this bit of information to everyone out there. Okay, so this video will more talk about the scalability and also will talk about a system design. So if you have system design interview coming up, or you want to know if you're working in a startup and you want to know how things work at big tech companies, how they scale their databases, how the infrastructure is, then this video will be really helpful for you. And also, if you are preparing for system design interviews, I have a separate playlist. So just to give you a bit of background, currently I'm working as a full stack developer at Booking.com, and I work on partner payment products primarily. And I live in Amsterdam. Before that, I had worked on AI and computer vision products, where I was the CTO at bigger company in India. So basically, I worked on travel chatbots, and also I worked on CCTV cameras, which is driven by artificial intelligence. And yeah, before that, for 2013 to 18, I was a co-founder at Schoolcom, where we built the product Smart App, which is used by 1,000 plus schools across South India. And I built a team of 50 plus people. So the overall experience which I have is building products and scaling it. And currently, I'm working on a partner side of it where I worked on a backend and front end, and also a bit of infrastructure as well. Also, I'm a mentor. I have mentored more than 10 plus startups from India, Europe, USA, and Nigeria. The companies like Andela in Nigeria, and there are companies, telecom companies based out of USA, and there are some other companies I mentored from Europe as well. I've also mentored nearly 1,000 plus students on programming and 500 plus developers on building products. Some of my students got placed in Amazon as well. This is my portfolio. You can please check it out, and you can connect me on LinkedIn or other social networks. You can find more detail about me on this website. So let's start. So basically, let me give you a scale of Booking.com. So if you see, Booking.com has nearly 29 plus million listing. They have 150 plus million active user, and we have like 700 plus million experiences. We have like nearly 60,000 plus servers. We have 10,000 plus databases, and we have 5 data centers based out of Amsterdam and London. We primarily use MySQL. So there are a lot of companies which primarily use MySQL, and in this video I'll be more talking about MySQL itself, how the MySQL topologies will help you to scale your databases or your database infrastructure so you can handle the multi-million user base easily. And also I'll be looking at how to scale your slaves in 10,000 database hub. So let's start with the master slave replication topology. So when anybody asks you like how you scale your databases, you say in database you do like two major type of operation. You do write and you do a read, right? So you prefer to have a master where you can perform write operation, and you can have slaves from there you can read it, right? So how the initial topology will look like? It will have a master, it will have number of slaves, right? Now consider the companies uh, like say Booking.com or Expedia or any other companies which has a large user base on every day coming up on their website. So your master can go up to the replication of 100 slaves in the peak time. So I'm saying like one database can have the replica of 10 slaves. Now, what is the issue with this topology? What are the drawbacks with this topology now? So let's see this topology. So we have a master, we have n number of slaves, right, which are different databases and the replica of it. So now, first thing I can see, like if the master fails, right, everything will go for a toss. That is the first thing, right? We will look into this uh, in the next stage of this presentation. But what are other issues with this topology? If you see, uh, let's say if the master is generating 1 MB of data, right, per second, that means to have all the slaves in a sync, you need 100 Mbps if you have 100 slaves, right? So that you can replicate the S1 and S2 with the same speed, right? So you can distribute the traffic, the read traffic on any of the slaves. So that means uh, it can, your in topology, the first issue is you need to have bandwidth. You need to have more bandwidth. So that's the issue, right? So how you can avoid that? We can discuss that. So if you see, the first drawback is the binary locks can saturate the network interface of the master, because if you have a huge number of slaves in the peak time, you need to distribute the traffic. Uh, Traffic in a sense, you need to distribute the traffic on the slaves uh, consistently, right? And your slave should be, all slaves should be at the same stage for the most of the time. And this can only happen if you provide a higher speed or higher bandwidth for a data exchange or the logs exchange from master to slaves, right? So you can saturate the network interface of the master. Now, when there are huge number of logs generated, if you see, when you delete a lot of records using single statement, when you say delete from table A, where uh, everything, where let's say uh, the true condition is for, let's say, thousands of records. So there will be a lot of logs will be generated. And also in the second case is like when you execute the online schema change for a table. So what does it mean? So let's say when you add a column to a table, so what happens internally? So what happens internally? It tries to first it tries to create a copy of a table, right? Or it just create the new schema and then start copying the data from the old table to the new table. And at one point, it just switches back. The new table will be the table will be used in production, and the old table will get deleted. Right? So there are a huge number of logs will be generated in such cases. So when the huge logs are generated, you can eventually saturate the network interface. So the solution is intermediate master. So the topology will have now intermediate master. Now you have slaves. M1 deal with S1 and S2, and M2 deal with like some Si to n number of slaves, right? So if you have 100 slaves, you can put, let's say, 10 intermediate masters. Now, from a main master, from main master to the intermediate master, you just need, if you are serving like 100 slaves, you need 10 Mbps, 10 MB per second on the master instead of 100 MB per second, because now you are distributing the traffic among 10 intermediate masters instead of 100 slaves. So you will not be saturating your network interfaces now. But this topology also has some issue, right? What is the issue? Let's see the drawbacks. Replication delay. Yes, because because you are because you have a intermediate master database, right? And then it's coming to a slave. So you are adding a replication delay from the main master. Okay. What else? What if intermediate server fails? Things will go for a toss. Now, this is a really important point. When intermediate server fails, now your, let's say M1 fails. Now your S1 and S2 should point to any of the intermediate master until the new intermediate master spins up. So your S1 and S2 has to repoint to M2. So there are some solutions like global transaction ID, GDID, to point back, but the issue is uh, these M1 and M2 are two different databases. So the problem becomes very hard when you have to repoint because they don't follow the same file system. Okay, so the solution is bin log server. Instead of having a database, you add a bin log server. So in that way, you will have a same file system across all the intermediate masters. So now the topology will look like with a triangular bin log server and getting rid of intermediate intermediate master database. Now you have a master, you have intermediate bin log servers, and then you have slaves. So what's the advantage of this? Bin log server will help you. So one thing is maintaining a database, intermediate master compared to the bin log server, right? It's easy and it's highly reliable because also like if why I'm saying it's more reliable, let's say if an intermediate master fails, it's very easy for you to point S1 and S2 to intermediate server like I2 because I1, I2, and IM, all those intermediate bin-log servers follow the same file system, and they are. It's very easy to recover the failover. Now, the main question, the first question which we had was, what if the master fails? So let's say you have intermediate servers and the master fails. What you will do to make sure your entire system work, the master slave topology works? Okay. So we'll try to promote most up-to-date slave to the master, right? What does that mean? Let's see the topology. So you have different intermediate servers and you have a master. When the master fails, you know, you, let's say you build a grain service. Grain service is like, which will have the meta information about the replication of the replication status of intermediate servers. So when the master fails, you can promote the intermediate master to your M to the, you can promote the intermediate master to the main master, right? But but here the issue is they're the bin log servers, right? So intermediate masters you cannot promote. So you need an actual database. If we were using the database which we use in the second topology, then we can promote the intermediate master. But here we have the bin log servers. So what we need to promote is the slave. You need to promote the most up-to-date slave to the master. Now how that happens? So once you promote it, you also have to repoint the other slave to the new master, right? So this is, there are two things. One is you have to choose which slave is most up to date, which has the most like higher, or you can say the latest replication time. So that should become the master, and also you have to repoint the other slaves to the new master. So what are the challenges? Okay, so First challenge is some slaves might be down for maintenance or for taking a backup. So once that is there, you cannot take those slaves for the real action of, of a master from the slaves. The second challenges will be some slaves could be temporarily unreachable for some other reasons. That can be some network reasons. And some may be processing a big backlog of relay logs. So they will be in a state of processing. So now what we do it, so if you see, this is previously we had like bin log servers. Now we have added a distributed bin log servers. So you see X and Y, right? So X and Y they present on a same server. So you can say if you resolve the DNS, you will be pointing to a same server. So X and Y are the two bin log, you can say two bin log files or intermediates which present on a same server. So for X should be replicating from A and Y is also replicating from A. But what if uh, okay, just to explain more because this is getting really complex. So you have now X and Y. X is a intermediate. So instead of having one intermediate binlog server, you have let's say two X and Y for the slaves. Similarly, you have Z and W for T1 to Tm. So now you see the difference between X, Y, Z, and W. So Z is, if you see W is trying to replicate from Z, right? And but as Z and W present on a same server, they're the two different binlog files, but they present on same server. Now, if the Z dies, it's very easy to recover. It's easy to recover the state from W, right? Because they are not on different server; they are on the same server. So if any issue happen with the binlog file, you can restore from W. But the W will be might have a slight application delay, very minor, very minor because they're on the same server. So that's the advantage of having a same site for binlog servers for a specific set of slaves. So this is how the topology look like. You have master, you have distributed binlog servers for different sites. Site means is a server where a DNS resolved for like multiple DNS, multiple binlog files can point to the same DNS. Okay, so now, so this was the topology. If you see, you have x1, y1 present on same site, and x2, y2 present same site. So y1 is trying to replicate from x1. Similarly, y2 is trying to replicate from x2, and everything x1, x2, and x3 are point to master. Now, when the master fails, each site might be a different position in the binlog stream or the failed master. Now here we need to do the action strategy. So basically the companies try to have the zookeeper to do the action. So what they do is they try to first level up. So we know x1, x2, and x3 are at the same level, right, compared to y1, y2, and y3. So once we level up, we know these are the servers or these are the slaves, right, which can actually these are like different intermediate slaves, right? We can say they can participate in the election because they have the most up-to-date information from the master. So what do we do here is we just uh, try to have volunteer for the master. So x1, x2, and x3 can be master. Right? So that's how we try to choose one of the master. So this is like whole master slave replication topology in detail. How companies try to use the binlog servers in between instead of intermediate databases to scale their master slave replication topology for hundreds of servers. And that's what happens. So in this video, I just talk about master slave replication topology, and this is how this is how it works in the real world. So I'll be having few more links where you can actually go through it and understanding some of the basic concepts about scaling databases in my video descriptions. So please go through that. And I'll be coming up with more videos on scalability, on cracking programming interviews, and as well as on startups. So please like and subscribe my channel and please support me. As I'm a new YouTuber, I really want to share as much as information as possible with you guys. Thank you for watching.